Hey, afternoon, everyone. I think we'll go ahead and get started. So my name is Ilya. I work at Google. I work as an internet plumber, performance engineer. I get to work with a lot of different teams within Google, outside of Google, and also get to work with the Chrome team and the web standards community as a whole, trying to figure out what are the things that we have, that we don't have, that we need to fill in to build performant applications. So I figured I'd come here and interrupt your two-day-long sessions of awesomeness of Angular with some somber words about performance, or hopefully not so somber. But all of that is a very long-winded way of saying that I get to spend most of my days writing long emails on standards lists and also looking at traces like this one, which I'm sure you guys are familiar with. And the awesome part about having access to tools like this is Chrome Developer Tools, is that you're literally 2 clicks away, right? You click a button, and all of a sudden you have all of this data right in front of you, available for every subsystem. And there's many different subsystems in a browser, right? To render applications that we build today, we're no longer building pages, we're building apps. And these apps live for a long time. So first, we have to load the page. And if you guys are familiar with my work in particular, you'll know that I can go on for hours about optimizing the network and all the things that you need to take into account for things like critical rendering path and CSS and JavaScript and how to make all of that load in a fast way. But of course, that's not sufficient because we know that we just lose the picture and the rendering's broken. Nope. JavaScript is also important, right? Because we're now shipping megabytes upon megabytes of JavaScript to render our applications. I know that applications like, for example, Gmail, literally take over a megabyte of JavaScript to power them. So this is a serious matter. Further, because we're no longer building just pages, but applications, they'll live for a long time. So we're no longer recycling our memory every couple of minutes. So these things are open for hours, if not days, at a time, and if you leak memory, that's a big performance issue. So memory is a thing too. But then, of course, we also have to talk about rendering, right? And if we talk about rendering, it's the whole pixel pipeline, it's the layout, it's the CSS, it's the compositing and GPU acceleration, and the whole topic of smoothness. And each one of these things has a different set of performance metrics. And then, of course, the more business-minded people in the room will say, yeah, that's all cool, but actually what matters is things like engagement, conversions, and visits, because even if you build a really fast app that can do all of these things in a super smooth, but is not actually converting, then what's the point, right? And that's the thing that we should be optimizing for. And this is all good and well, and all of these things are important. And that, in fact, is the biggest problem that I run into personally when I try to work with various teams. Because what this actually points to is the fact that the web platform is arguably one of the best and well-instrumented platforms as far as performance goes. We don't have a lack of metrics. We have an overabundance of metrics and tools, and that in itself actually creates a different problem, which is when you open that thing and you look at all of the metrics, when everything's screaming at you saying it's important, nothing is, right? Because you have no idea what to pay attention to. And that, in fact, is the biggest challenge and problem that I have to deal with when I start working with a new project. It's like, let's define performance. Let's define success, right? So let's actually do that. So what is performance? There are many different definitions. This particular one is one of the more vague ones, but I actually like it because it defines performance as something that is seen in terms of how successful it was performed, right? So the obvious question is like, what the heck is success for my application? And how do we measure success? So let's do that, right? Well, imagine we're having a conversation. This is very typical in my workflow. We say, okay, let's sit down. What is success to you? How does performance and success relate? And the first thing that gets thrown back at me is like, well, we know that success is a function of performance. As in, if we have very poor performance, we're going to have low success. So it seems intuitive to just assume that the more performance you add into this thing, like some magic fairy dust, the more successful you're going to be. And generally, that's true. Then we start iterating on this line of thought, and we say like, well, let's talk through some particular examples where something has failed or was not performant enough in your application, and let's backtrack and figure out how does this actually look. And at some point, we actually arrive at a slightly more interesting and complicated and comprehensive model of performance, which says that at a certain point, right, so let's say your application response time is 5 seconds, and you have put a bunch of engineering effort and you move the needle to 4 seconds, which is actually a great performance improvement if you think about it. But then you ask the user, and the user probably didn't even notice, right? To them, it was damn slow, and it's still damn slow, and it's still too damn slow. So at a certain point, there is that cliff where you say, the user says, like, no, this is unbearable. I'm not willing to put up with this, and there's a competitor that I can go to, and I will use that, or I'll just abandon the thing altogether, right? Like, this was a fun experiment, but I no longer need it. Then there's the kind of bearable experience, or maybe something is forced upon them where they don't have a choice. And that's an unfortunate place to be as a user, but frankly, that's where most of our applications are today, right? Finally, you get to a point where you have that experience of user delight. You have an application, at least one on your phone somewhere, that you're happy with, that you know that it responds all the time, it never blocks. It responds to your intent and allows you to get the thing that you want done very quickly. And that's where we want to be, right? And then finally, after a certain point, you say, great, so my response time is 250 milliseconds. I can spend X amount of engineering effort to bring that down to 100 milliseconds. Is that worth it? Well, it may be, depending on your context, but maybe not. And that's the space that we need to explore with each kind of project and team to figure out, how does this fit? So you would think that given kind of the contextual nature of all these things, that this would be all over the map. Every application is slightly different, and it's true, right? Like, each one of these cliffs, if you will, is going to be different. That said, one consistent thing that we do see for a lot of these applications is the fact that there's such thing as too slow, right? So there's a minimum viable product that you must ship for it to be acceptable to the user. There is that big middle zone where you have a lot of leeway to figure out, like, what is functionally useful and what is good. And at a certain point, you do hit a ceiling where you could continue adding things and improving things, but you're just not getting the same multiplier. You're probably better off just adding or spending the time working on better functionality or addressing other bugs or issues. So the question becomes, what is this? How do we define it? And how do we organize all of those metrics, right? Remember the dashboard, the trace that I showed you with lots of different metrics? How do we think about that holistically to answer this question? Like, am I in this user delight zone? Or am I out of it? And what are the important things? And one way to frame this is actually a conversation that we've been having within the Chrome team for a while, because we have a similar problem, but from an instrumentation point of view. Like, there's many different components in a rendering engine or Blink or Chrome as a whole. We need to optimize all of them. How do we know what to prioritize? What are the things that are hurting performance of current applications? What metrics do we surface in DevTools? What do we tell developers? And all this kind of stuff. And what we realize after a lot of kind of talking is that frequently as developers, or most of the time actually, we focus on the silicon, right? There's actually two processors that are involved in consuming an application or an experience. There's the silicon, which is running the thing that you guys wrote, but then there's the wetware, which is the other end that is perceiving whatever's being generated by that application. And this wetware actually has a bunch of input peripherals with all kinds of interesting and weird characteristics. So, for example, you take the silicon processor and the wetware processor, and that's what you get by combining the two. You get the perceived performance, right? Where you can actually have a very fast application that is very slow in helping the user achieve their goal. And that sounds very abstract, but we'll look at some examples. And vice versa. You can actually have technically slow application, which is able to fulfill the requirements that the user has out of it. So that's perceived performance, and of course, today we oftentimes call that user experience, right? Like, what is the outcome of all of this? And these two things, it's important to think about these two processors in conjunction. And here's a fun anecdote. It's an example. It's an interesting experience for us within Google. This is back from the early days of Blogger, where the team had to rewrite their backend when they migrated onto Google infrastructure. And they did a fantastic job of it. They launched it, and the user would go through the entire process of filling out all the fields they wanted, how they want their blog to look, and then finally you hit the button to create the blog. And that process was so fast. It was effectively instant. Like, I don't think there was even a page reload that a lot of users thought it was broken. And we only discovered that after we launched it and then started looking at the logs, and we realized that a lot of users were clicking back, spending a bunch of time on the page, I guess checking what they saw there. They didn't actually change anything. So it's not like it was an error in the fact that they typed in a wrong blog name. And then they would resubmit the same form. And we're like, what the hell, right? And after scratching our heads for a while and actually doing some user interviews, we kind of pinpointed it to the fact that users expected that thing to be slower. I don't know, something in our brains, maybe it's like the commitment of like, I'm going to create a blog and I'm going to write on it, right? That feels like a big step, and all of a sudden you get that instant response where users thought it was broken. So the fix was actually trivial. We added a gratuitous spinner that sat there for 200 milliseconds and then advanced and did the thing it did before, which is create the blog. But all of a sudden, all the users were happy. Right? And this is performance. This is perceived performance. And it's like, it's kind of funny to talk about it. And then like, you know, the new meme is to put spinners everywhere. That's not the point, right? The point here is that by technical metrics, we succeeded. By user perceived performance, we failed. And there is a time and place for affordances like extra animations, transitions, and other things that can help the user cognitively understand what is happening within the application that are independent of these technical metrics. So let's look at some of the performance specs, right? So there's a couple of inputs that are particularly important to us, and I think it's good to contrast them. One is sight. So it turns out that back in the day when the film industry was starting up, they figured out that the minimum viable product for creating animation that does not suck and does not seem like it's stuttering while you're watching a movie is 24 frames per second. And hence they started filming everything at 24 frames per second because film was expensive. And that is how we arrived at 24 frames per second. Now since then, we've built a lot of other infrastructure. The film became a lot cheaper, and our screens refresh at 60 FPS, and we've discovered things like motion blur and other things, and we converged in this value of 60 frames per second, where we know that if you deliver consistent 60 frames per second, that is, in fact, the best experience you can deliver visually to the user, which means that, in return, we have 16 milliseconds to paint every frame, right, to update the screen. 16 milliseconds. Now, contrast this to something like audio input. It turns out that we are actually much more sensitive to audio discontinuity, where even 1 millisecond jitter we will detect. And while you may not be able to describe exactly what happened, you will know that something's not right. Which is why things like VoIP and audio systems are much more sensitive to latency. This is why they use different protocol stacks. This is why they go to great lengths to adjust the quality on the fly and all the rest. Now, the interesting other story about audio is that despite the fact that we're very sensitive, we're also very good at ignoring entire missing chunks of audio. So you could drop 50 milliseconds of audio on the floor and continue playing the next bit, and that is better, we detect that as better than janking for 50 seconds and then starting the playback later. That does not work for frames, right? So we have these different peripherals, they have different characteristics in the way we process this stuff. And it's important to take this into account when we're building your application. So if your application is working with audio, you're going to have to focus quite a bit on this low latency, right? With frames per second, we have a different metric. Now, let's talk about perception reaction times. So there's many different metrics that you'll find in different studies that measure what is the response time, what is the human response time. And the honest answer is the number varies quite a bit depending on the context, environment, and the amount of data that you're exposed to and all of these things. That said, there's a number of user studies that have been done for things like interacting with applications, with computers, and all the rest. And more or less consistently, we fall into these buckets, where to most users, a response time below 100 milliseconds feels instantaneous. Somewhere between 100 to 300 milliseconds, some users start reporting what we call the sticky button, whatever that means, right? But you guys know what that means, because you've felt it before as well. After about 1 second, some users start to context switch. So I had the intent to do something, so I click a button, but by the time a second passes and there's no response, I'm already onto the next thing in my head, right? It's like, oh yeah, I gotta go get a coffee, or I gotta call this guy, or do something else. And that interrupts the flow of the application, which is a bad thing. So as you'll see, we'll actually use these metrics to kind of backtrack into what does performance mean, and what is this user model. And I want to come back to the beginning and say, like, so what is performance? How do we define performance? Specifically for web applications, I think it's this intersection of, or overlap, of meeting the wetware's perception reaction expectations. So as long as we stay within that golden middle, we're good. Which is another and very long-winded way of saying, focus on the user and everything else will follow, right? Which seems like an obvious statement, but it's interesting to look at the statement from perspective of, like, what are the metrics that matter? Given that giant dashboard of performance metrics, what are the things that I actually care about? So while evaluating this model within the Chrome team, we went through this exercise at the beginning of this year, trying to understand and organize our own efforts. And we came up with these 4 categories: response, animation, idle, and load, which are the performance rails, if you will. So let's take a closer look. We have the load. This is something that I've been focusing on for quite a bit of time. And the goal here is to deliver a page, to deliver a response to the user that they can interact with in less than 1 second. And this is a very complicated thing to do, as it turns out, right? Because it involves fetching the HTML, fetching the JavaScript, the CSS, parsing all of it, building all the trees, laying out the page, painting the darn thing. Like, this is a very challenging technical problem. And due to the constraints of the various network protocols and the network that you're on, this turns out to be a huge, huge challenge. So we don't have time to go into the specifics of how you would go about doing this, but there's great resources on the web that you can find that will talk about this and walk you through the kind of the required sequence. But one thing I want to highlight here for load in particular is that I'm not talking about loading everything in 1 second, right? That may not even be technically possible for some of the things that we're building. But what we're talking about is delivering progressive rendering. The difference here is a page that loads in 7 seconds, whatever load means, right? And imagine you have a blank page for 7 seconds, and then boom, the whole thing is painted, it's fully functional, and everything is great. Versus deliver an experience where the user sees something at 1 second, they're able to start consuming the content, interacting with it potentially, and the remaining content is actually loading in the background. And one of the best examples today that I see of this is actually Amazon.com. If you look at Amazon, they load a lot of content, lots of product images, they're fetching stuff on demand. And if you look at the technical metrics for that page, you'll see that it's taking like 10 plus seconds sometimes to load the page. But in reality, as a user, I never feel like it's taking that long because the page is loading very quickly and I'm able to interact with it, and all this stuff is just happening in the background. That's what we mean by delivering this interactive content in less than 1 second. Then, once you've delivered the 1 FPS, right, that's the first frame, it's taken us 1 second. We need to repaint the page every 16 milliseconds, as we said, because we need to deliver 60 FPS. And this pixel pipeline that consists of potentially executing JavaScript, maybe doing a style recalculation because you've modified some component of the DOM. Maybe we have to relay out the page. We have to paint the actual pixels, ship them to the GPU, and do all of this kind of work. You know, that's a complicated pipeline. And you really need to think about how much work am I triggering whenever I'm changing, say, some attribute on my or DOM property somewhere else. So once again, we don't have time to go into the details, but Paul Lewis recently produced a Udacity course and a really nice guide for how to think about this whole thing end to end, right? Kind of from the fundamentals of like, what is this pipeline to what are the things that you should avoid. And one other thing that I think is important to highlight for animation in particular is that consistency matters. So consider 2 different examples. 30 FPS, but for the first half of the second, we don't do anything because we're janked. And then I deliver 30 frames versus 30 frames that take 32 milliseconds consistently. Which would you prefer? This is similar to the progressive rendering, except as it turns out, just the way we perceive performance, consistency is really, really important for animations. From the games industry, we actually know that if you have variation in your frame rate, say you're going up and down, sometimes you're 30, sometimes you're 45, sometimes you're 60, that is actually worse than delivering a constant 30. So if you can't hit a consistent 60, then you want a consistent 30. You don't want to be all over the map and jumping up and down. That's just the way our brain works, which I think is quite interesting. Next one is response. So as we said before, and there's actually 2 different types of responses here. First of all, we want to acknowledge the user input within 100 milliseconds. As in, the application should indicate something to the user that, yes, I've understood that you've expressed an intent to do something, and I'm doing it, or I've finished it, right? It doesn't mean you have to have finished it by that point. So if you, for example, sending a request somewhere, you don't have to block and wait for it. You could just indicate that, yes, this thing is working, and periodically I will update you. But at the same time, 100 milliseconds is for responding from the application side. You still have to acknowledge the visual aspects of it much sooner, right? This is the 60 FPS. So here's an example. This is actually a video from Microsoft Research.
We used our test setup to examine different latencies.
Can we turn up the volume on this?
That this is about 100 milliseconds of latency. We're not moving at a full meter per second, but the delay is still very clear. Now,
can you guys hear that?
That's significantly better than most devices on the market, but it's still quite a bit.
Okay, let me rewind here.
How much better the experience would be as we decrease that latency. We used our test setup to examine different latencies. So here you can see that this is about 100 milliseconds of latency. We're not moving at a full meter per second, but the delay is still very clear. Now, that's about the level of current devices. If we move this down to 50 milliseconds, that's significantly better than most devices on the market, but it's still quite a bit of lag, even at these slow speeds. Now, if we move that down yet again to 10 milliseconds, you can see it's dramatically better. In each of these steps, the user preference is very clear that it just gets better and better. But if you look closely, you can see it's not really staying on the finger. It's kind of rubber banding around it. So if we move all the way down to 1 millisecond, then you can see now it's really staying on the finger. And in fact, if you were playing with the real setup, you would notice a real perceptual cliff, that this really starts to feel like a real physical object. If you take a look at it.
So I think the last thing that he said was actually very important. It's that perceptual cliff that when we went to 1 millisecond, it starts to feel like a physical object. Right? That is the experience that we want ultimately to deliver, and that's what we're trying to achieve with these goals. And once again, this is a user-centric perspective on this whole thing, and which actually takes us to the last point in this whole rail model, which is idle. And the way to think about this one is, in order to acknowledge user input, to process the user input, and to allow the system to actually execute its pipeline, the rendering pipeline and all the rest, you have to, both the application and the platform, has to yield control very frequently to allow other more important things to run, say a user input, a touch handler, or something else. So we have to chunk our work and make sure that we avoid things like, hey, I just had 300 milliseconds of JavaScript execution, right? Because in the meantime, the user is not scrolling, we're not reacting to input, we're not doing anything productive for the user. So we want to maximize the main thread idle time. And this is an interesting one because coming from the platform side, this actually has interesting implications for the browser, right? For how we schedule things. Previously, we would optimize towards maybe how quickly we can execute all the tasks backlogged in our queue. Whereas now we can actually say, well, hold on, user input matters more, so maybe we need a priority queue and we need to process certain things, and maybe we need to provide a new API to web applications that are able to say this is more important than this other thing, right? Like if you have background work and you want to execute it in some idle time, how do you do that today? Well, you can't, frankly, right? But that's where the platform can come in and propose a new API, which actually is something that we have we're working on in Chrome called set idle frame or request idle frame, like RAF, except for idle time when we know we have a bit of time to do some background work, and maybe that's something you guys can use to execute background tasks. So to bring this all together, the interesting part about working through, in my experience, working through with all the various teams and different products is that regardless of the product, we still arrive at the end of the day at kind of these fundamentals, right? Where we know that we need to load the page in less than 1 second. That's an acceptable experience. We need to acknowledge the input in 100 milliseconds. We need to run our animations at 16 milliseconds. And we need to maximize our idle time. And all these goals work together to create the user-centric performance model, if you will. And this is useful for us both on the platform side because we can now frame this entire conversation with respect to these goals and figure out how to prioritize them, right? So within Chrome in particular, we have different sub-teams for things like, well, you guys work on the V8 engine, you work on the rendering pipeline, you work on the painting pipeline. And of course, if you talk to any one team, they'll tell you that their thing is the most important one, right? And yes, we need a new panel in DevTools to explain you all the painting costs. And yes, we need a new panel to explain the V8 costs and all the rest. This allows us to actually bring that all together and say, yes, but if we just swamp the user, the developer, with all of this data, they won't know what to optimize for. And I think it's interesting because it's been so instrumental for us, and I would encourage you guys to also take this and consider it in the context of both your application. Like, I have a dashboard of metrics. How do they correspond to this sort of model? Where do I fit in this model? And also for something like a framework, which I think is doubly important because you are laying the foundation through which the other developers will actually either meet or not meet these goals. So with that, I'll give you one last link, which is, I think, an interesting read, especially if you're interested in kind of the inner workings of Chrome and are thinking about this problem. We started this effort under the name Midnight Train. Where that name came from, I have no idea, but it has eventually evolved into this Rail model. And I would encourage you to read through it, even if you're not a browser engineer or aspire to be one, because I think it'll help you inform kind of your own thinking, how to go about it in your own framework or in your own application. And with that, I'll leave you guys with the link to the slides. And if you guys have any questions, I'll be around and I'm happy to answer them. Thank you.